Hey everybody, welcome back to LeetCode. And today is the day. Today is December 31st, and it's the last day of December LeetCoding challenge. As you see, I haven't been a particularly good LeetCoder this month, so I haven't solved a single problem. But on the other hand, it means that we actually can solve all the problems today. And they should get released. The last problem should get released right now, I believe. So I've taken problem names and we'll be doing some sort of speedrun. But of course, just watching me solve problems is not particularly interesting, so I will explain the problems along the way. So let's go. Maximum depths of binary tree. We're given a root, we want to return max depths. We guarantee that there are not all that many nodes in the tree. So what we can do, I believe, we can write a recursive function. Base case, if it's when the node is leave, and the node is leave if it has no children. So if not root left and not root right, then we can return a depth of 0. Should I return the depth of 1? 1. Okay. Also, if not root, then I can return 0. And, otherwise, I just return max, I believe, of max depth from root left, max depth of root right, and also +1 for the root itself. Okay, didn't put another plan here. Okay. Again, there is no convenient button to copy all the test cases, and it also automatically runs visualization, whatever. So we have test cases like that. Right, so they don't note it as such. Let's go. It passes samples. Okay. Linked list random node. We're given single linked list. We want to return a random node's value from the linked list. Same probability. Okay. What's the point? Okay, so we want to run some sort of random access to linked list. The length is unknown to me. It must 10 to the 4 calls. And we know that length is up to the 10 to the 4th. Well, what I can imagine is that, let's say we pick, well, obviously the fastest solution would be just to store every node in every node's value in some sort of array, but it's not particularly interesting. I believe we are interested in something like random increments, right? So, so we choose the step, so the number of nodes we want to ignore before we actually return the value, right? So we will also need in C++ some sort of Mersenne twister engine. Is it like so or like so? Yeah, right, right. 19,937. Okay. Generator. Whenever we will also need to do some sort of distribution, which is uniform int distribution, I believe. And you have to specify like int and 0. Then, for example, we want 10 to the fourth. Int steps. I'm not sure. Let's copy head and initialize node with head. The idea is that we store current node and head in case we ever want to go to the beginning. It's not correct. This is correct. Okay. Now we get our number of steps. And notice that random generators in C++ have to be defined on class level or whatever level where they are not copied, because I mean they are not constructed all the time, because they are pretty hard to construct, I believe. Okay, so now we just need to make some steps. I'm not entirely sure whether or not it's the expected solution. Potentially, I mean, once we seen the entire list, and it becomes kind of unnecessary to look over it again. Maybe then we can add nodes to some sort of array and then pick index at random. Okay, so if node, then a node gets node next, if not else, right? So if we have a node, if node is not a null pointer, then we are expected to go to the next node, otherwise we shall turn to the head. And of course, I'm missing underscores. I believe it's the current naming convention. And there's no underscore in next. Kind of long on this one, but again, it's not properly defined statement, I think so. Well, sort of random, actually. Potentially, we want to make at least one step. Well, probably it happens. I mean, and we're always returning the same answer. Okay. Yeah, let's try. I think, I mean, yes. Okay, good. So we just In case we don't want to store the entire list, then we randomly pass several elements, and potentially, no, I mean, it could be beneficial to store like to go to the next element, next nodes, like in binary manner. I mean, go. Yeah, so for example, if we had like step of 101, then we could pre-compute some pointers to like this element 64 to the next and 32 and so on, but I believe it still makes a lot of memory, so that's why we're not using it. Increasing order search tree. Given a root of binary search tree, rearrange tree in orders that left must not be. Okay, well, I mean, we obviously can just do in order traversal and then construct a tree with this from this order, right? But what I believe we are expected to do is to rotate the tree. So that's okay. Okay. So I believe we can make a recursive function. We will do it. We'll take new left root. We only need it if root has left children, left child. Yeah, so I'm writing a recursive function. And it will actually, yeah, we don't need this if girls. So we call function recursively from left and right subtrees. Then we want to append like root to the last element of left subtree, right? So if there is left subtree, and we take nodes equals like this root, while not right, nodes equals not right, then we do what? So here we get to the last node of left subtree after it was processed, and we select node right gets root. I think root left gets a null pointer. Root right gets new right root. Otherwise we just have to process right subtree. And here we can we shall return a new left root. And here we return a root. I think this is how it goes. Hello. Actually, now that I think about it, if we spend 5 minutes per question, and it's gonna take like 3 hours. Is it correct? It is correct. Maybe some weird stuff. I don't know. Are we guaranteed like at least one root? At least one mode? Okay, yeah, actually we are guaranteed at least one mode. Yeah, let's try to submit. I believe it should work. Okay, good. The case factor of n, so we given two positive integers n and k, we want case factor. Okay, so n and k are pretty small. We can just loop through them, right? It won't be interesting. So let me do this. And the faster way would be to, we know that more or less like plus minus one half of the divisors of n at most square root of n, right? Because they are paired. If you have a divisor which is smaller than square root, then you automatically have a divisor which is n over d, right? D and n over d, one of them is smaller than square root, the other is greater. And it means that we can write algorithms that works in square root of n steps. Let's do exactly this. We have divisors. Like to loop over them. Vector or yeah, vector will do. Vector will do. So we have divisors. We'll loop through them as long as they are smaller than square root, right? If n is divisible by this, and we decrement k. If not k, meaning that we got to like what? We got to the case divisor, and we can return d. And we also want to push back it into divisor so that after this right, there is an if. That should be for loop. Okay. And now that I think about it, we would like to keep. Oh, okay. Yeah, so what happens is that if our divisor has a pair that's bigger than n, then we push back it. Now we process all the elements, all divisors that we push back, and I think that we can immediately push back like the correct divisor. Okay. So we decrement k. Now, if not k, then we can return divs back because that will be the divisor. Otherwise, we have to div pop back like that, but like that. Otherwise, we can return -1. Right. 724411. 724411 1003. Seems correct. Good. Can place flowers. You have a long flower bed, which some of the plots are planted and some are not. Pots. Isn't? Okay. Flowers can be planted in adjacent plots. Okay. Okay, so basically we are interested in how many flowers can be placed in like. All right. I think we have a straightforward linear solution for that. That's it. Let's get, and I don't want to write this name all the time, so I don't want to write this name all the time. Or int I gets 0 I smaller than n. So if fi not fi and not f minus small 1. Yeah, and I shall do it like that. So yeah, so what I want to check is that whether or not we are obviously okay with greedy approach to this problem. Just put flowers from left to right wherever you can, because what bad can happen, right? If you don't place flower here and place flowers later, and we will end up with one of two solutions. When we have a subsegment of zeros, so there are no flowers, and we can just the max number we can what number of flowers we can put into it is depends only on length, and it's approximate length over 2, and it can be obtained greedily. Okay, so and once we've done that, I believe I'm missing a parent here. Okay, so if everything is correct, oh, that was then we want to return that n is less than or equal to 0. Yeah, so we basically planting flowers until we are completely bored, not until we get plus n. We obviously can add a switch here, but what's the purpose? Hello? Hello? Oh, an error. True, false, that's correct. These two are correct. Oh, interesting. Okay. Why is it so actually? We should not output. Okay, here. Am I missing something? I mean, if neighbors are not plotted, right, then we can do it ourselves. It's kind of slow though. again. So it seems that we can put a flower here, which is not correct. Right, because obviously we want to check that condition and not the previous one. What I was thinking about, yes, obviously. Yeah, so the problem was that I can't write, and we wanted to check whether the index is lost or not, and we checked whether it's not lost instead. Good. Populate next right pointers in each node. Have like what, binary tree? Not binary tree, but some other tree? No, it should be binary tree, right? Okay, so we want to connect. Interesting. Well, obviously we have to connect left child to right. So if root has left child, then root left next gets layer by layer, right? Okay. Gets root right, and also, so we will need two nodes, a left node. Well, yeah, what I want to do, actually we have to write for the first time, draw, I mean, is once we created all these pointers, it remains to merge. And to merge, we take like, we first go to the left, but then we always go to the right. And here we first go to the right, but then we go as left as possible. And we draw these edges between subtrees. That's the idea. So left node gets a root left, right node gets a root right, while left node and right node, we should do the following, like, actually this is unnecessary, because this will be the first action, like here. Left node next gets right node left. If left node has a right child, and we are interested in going to right child. Otherwise, we have to resort to going to the left child instead. Because the left child in this case is kind of rightmost child, right? Because you have no rightmost child, the left child becomes the right child, the rightmost child. If here we have for right node we have left child, then we go to left. Otherwise, we go to right. And then we want to connect left subtree right. Only one sample. Let's check. Something went wrong. I exactly did something went wrong. Are next pointers initial? Yeah, they are initialized null. Okay. I'm not exactly sure what this means, that we got 1, 2, 4. But it says that we should get 1, 2, 3. Also layer by layer. So we did not. I don't understand. We definitely do assign, like here. Okay, let me output pairs that we are connecting. In this statement, we are not connecting anything. How could it be? Oh, well, of course we're not connecting anything in general, no work at all. Undefined behavior, member access within null pointer. Where exactly? If not root return null pointer. Is this it? Yeah, it appears to be it. Kinda complicated. Is it because? Yeah, whoa. That's kind of tricky. So the rightmost node on the layer is not necessarily the child of the rightmost node on the previous layer. At this point, I think that it will be easier just to do some sort of BFS. Okay, yeah, okay. Because our recursive approach failed. So we will maintain a dequeue, which is like a two-directional queue of nodes, while it's not empty. We want to process one layer exactly. We will do it by grabbing the size of BFS. And then we will process k elements from the queue in the following order. Well, first thing that we want to do is DEQ has want to process the current layer of DEQ. So BFS I next gets BFS I plus 1. Otherwise, we take a BFS front, then a pop front. If a node has a left child, then we push it back to the BFS DEQ. If it has a right child, then we push back right child. Then we can return out. Wait, we can only use constant extra space. Well, okay, I believe that there is some sort of smart reversal that takes care of case that we ignored. Yeah, well, I think that we should store like stack or something of nodes, and it will be it. Okay, stack of nodes on the path. But our iterative version is also not all that bad. Is it not correct? Our guarantee is at least one node. Well, if it's like 0. Okay. Yeah, sorry, I'm kind of slow on that problem because yeah, our initial approach failed. It's really, really slow. I can't work with it. Yeah, looks okay. Oh, now it's working. We got to speed up a little bit. Okay, spiral matrix from 1 to n squared in spiral order. Not a problem. First of all, we will create the matrix itself. Then we will grab row and column, which are initially set to 0 and 0. Then we want a vector of direction, so we will have like sequence of direction. What is the next move, right? Next move is always turn 90 degrees to the right. If we can't move in the straight line. Or actually, initially dr is 0, dr is 1, dc is 0. We don't, no, dc is 1, dr is 0. We don't change the current row, we increase the current column. And then to turn to the right, I believe we can work with indices, right? I mean, it's like rotating a complex number consisting of these two by 90 degrees. I think we can do it. So m at row column gets I plus 1 if m at row plus d row column plus d column is equal to 0, it means that we can move forward. And we should also check that these two indices are correct. Let's check that first. The row is correct. It's within the boundaries. Let's check the same thing for the column. If these are correct, and we do this, else we have to think. If we are currently incrementing row, yeah, column always gets row, but row gets minus column, I believe. So if we go in here, here, right. So that's the rotation 90 degrees. And I think we can do it like this. So if instead we check that if indices are invalid, or we have a value in the cell that we are going to, then we have to change our directions and only then make a step. So on the following iteration, we are always in the correct spot. Kind of bad. Why exactly? Can we have like 1, 2, 3? The idea is that we originally start moving to the right. Yeah, I have to print current row, current column. So we started at 0, 0, then we went to 0, 0. Why exactly? We were supposed to move. Because that's for 1. So then we move to 0, 0, then to 0, 1, then to 0, 2, and we should not move to 0, 2, because 2 is outside of the boundaries. Yeah, because the conditions are wrong. If any of these fails, then we have to rotate, change the direction, because we can't go there if any of these fails. Why is it so slow? I bet it's not a non-error. Okay, we'll have some output. Okay, this is not valid. Oh, exactly. We kind of stuck in the same place, are we? Right, right, because these two have to be inserted in the same time. So changed. We have to change our direction simultaneously. So otherwise, do we have to like std make pair? Huh? Addition of unsigned offset or false. So we got to -1. Well, I thought we are trying to. Okay, so DC change in column. No, I was wrong. Okay. The signs are in a different way around. Yes, now it's correct. Okay. Sorry, guys. It's morning. Not very good at rotating complex numbers in the morning. Okay. Pairs of sounds with total duration divisible by 60. Okay, I believe it's frequency map and nothing but that. We need frequency of 60. Only interesting thing is what happens when you have like 30 plus 30 or 0 plus 0, right? I'm not sure. I'm not sure whether or not the total number fits. I feel like it does not have to fit. So or if I equals 0 or I equals 30, then need to add and choose 2, where n is fi, so that's fi times fi minus 1, because we are choosing from the same set of objects, right? We have to do this. We also have to, okay, we can do it like this. Else we add, actually, now that I think about it, we want, or are we interested in, yeah, in ordered pairs? Okay, so in this case, we only loop up to 30. And we take 60 minus I instead. We can actually, oh no, okay, that's fine. Why does it says integer? Like one day, because we have chose k. So it should be correct, like, because at most number of pairs is this number choose 2, which is 1.8 times 1 billion. Good. Binary search tree iterator. Oh no, we have to write iterator. I mean, the only reasonable thing is, yeah, we need height of the tree. Okay, that's okay. We will need a stack of vertices, so because we can't have like a cursive in order traversal, means we will need stack of 3 nodes. And we also, yeah, we will need number of times that we have visited this node, so that we know where to go after we visit it again, whether we should discard it and return upwards, whether we should go to the left tree or to the right tree. So initial path equals root 0, I believe. I hope it's correct. Okay, so next, how does next work? While not stack empty, what do I have to return after, like, we have has next. It has next. How do you know whether or not we have next? Okay, I think we will return not stack empty and ensure that we process stack correctly after. Pointer. Okay, and all next calls will be valid. Okay, so what we will do is the following. While we have at least one node in the stack. We take pair node and visit time. The visit time is 0, 1, or 2, depending on how many times you visited it already. Actually, we are not out. So if visit time is 0, it means that we have to insert left node if there's any. And place actually. Not left 0. If there is no left node, else we have to increment visit time because we effectively visited the left subtree. Now, if visit time equals 0, it means that we have already traversed the left subtree and we returned from it. We want to go to the actually look when we in place, right? Means we are going to this left node, or are we? No, we shall go to the right. While pass top left should in place left we want to start with leftmost node. Okay. Also, I wrote stack everywhere. And, my intention was to write pass. So we take the current node. If visit time is 0, so it's the first time we visit this node, right? And then we go to the left subtree. If it has, otherwise it has not. Okay. So if visit time is equal to 1, it means that we returned from left subtree. And we would like to, yeah. Every time we increment visit time, it is the same as we visit a node for the first time. It means that we have to return node value. Yeah, and then else if we returned from left subtree already. So we traversed the entire left subtree. And we not here, I think, not here, but here. So when we return from left, right, it's tricky. we returned from left subtree. We want to, in order, we actually want to return the current value, right? But it looks like we are doing something wrong. If it's the first time visiting node, then we go to the left. If it is, if the node, however, has no left, and this is it. This is it. Otherwise, if so here, every node that has visit time equal to 1 means that it's been already visited, and we have to go to the right subtree, right? So that's how in order works. So if node right and pass in place node right visit right for the first time. So every time we in place the visit is 0. Is it though? If it has no right, then we have to then we so if it has no right, then I think we have to go upwards, right? So we are done with the current node. If we wanted to traverse right subtree, but there is no right subtree. And also, we want to have like visual distinction. So visit time is 2, right? If we already processed a right subtree. And basically, in this case, we pop an element from the stack and again increase top. Whoa, it's tricky. Man, but yeah, our operations work in no viable overload. Okay, what's our pass in place root 0. I saw that you can initialize stack with like initializer list, and then inside you initialize the pair. Potentially I am wrong. Hello. Excuse me. We are trying to do something here. Can we please have our solution tested? Yet again. What is that? Huh? Member reference type. Yeah. While pass top first. we want the node because it is a pair. Correct? It's not stack, it's pass, 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 pass. What is that? Ah, here we return something, right? Somewhere around. Where actually? Line 43, turn pass top well. Yeah, because we want to pass top first. Well, you hear? Actually, why is that? No. No, 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 no. We are guaranteed that we return it there. Yeah, this function returns integer, and when we do not return, we want something went wrong. We went to 3, but then we never came back. Actually, I mean, it makes more sense to return value here, and here you can do like that. Here you can do like that. It's the same thing, more or less, but in slightly order. Because we unpacked. Is it though because we unpacked? I'm no longer sure that that's because we unpacked. We have like plus plus with time, right? I'm still not sure. Okay. Oh, it's so laggy now. Almost impossible. Yeah, so I would like to see what we are doing here. Namely, what we are doing here. So we are stuck at 3.1. 3.1 goes here. It returns. No, 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 right. Right. It's tricky though. Maybe we have to return like here actually. Well, So we went to what? We went to null pointer somewhere, right? So we were first initially at 3, 0, and at 3, 1, we outputted 3, then at 7, 1, we outputted 7, then we went to 15, 0, which is correct, and we went to 9, 0, which is correct, and to 9, 1, which is correct, 15, 1, which is correct, 20, 0, 21, 15, 2, 7, 2. Okay. We actually, yeah, potentially, if pass empty, it only makes sense to access top when pass is not empty. Wait a second. Oh, okay. So do we have, don't we have like, okay. Potential, the problem was that we were like returning values 1 too early. I think this was the problem. I'm no longer sure. That's not correct. Okay. Went to 3, then we jumped to, and we jumped to 9. Whereas we should actually jump to 7. Our top here is 3, 1. It has no right, so it increases its time and gets there. And it increases past top. Second. And, if it's the first time we increase with the time here, and we would like to yeah, first visit can happen not only when we can go down, but also when we return from left subtree. Why is it so actually? when 20 got visited. Oh, okay. Well, you know what? I mean, next is kind of good to determine whether we have next or we don't, right? Let me also make a quick fix like that. So ready equals true. No, ready equals false. Values, do you know anything about values? Right, okay. Yeah, the idea is to, like, every time we have to determine whether or not there is next, we check, we go to next, and we check. Here we set ready to -1. Here ready gets next. Return already not equals to -1. Will it work like that? No. Yeah, because here when it's ready, we want to return ready, but we also want to reset ready. Wow, iterators are very tricky to implement. What happens? Oh, actually, I'm interested what happens. So we went all the way up, and then we failed. Yeah, because this has to be included here. Again, access on top where there is no top. Now we actually get it somewhere. I think that we are doing like exactly the amount of work expected from us. Okay, good. Whoa, that was very long. I mean, yeah, I don't. We've seen this problem on sample interleaved mountain array. You can check whether or not they're like. So the first thing you want to check is that boolean has contain. right? And also you want to check like has valley. Let's call it valley. Has mountain will correspond to actually heaven, the peak, right? Peak. And have valley will correspond to heaven, like something that is broken, something that is not like that, and not like that, and not like that. Okay. Grab ourselves size. All of these conditions, like being a mountain, being a valley, depend on three numbers. So array at index -1, array at index +1. If array at index -1 smaller than array at index and array at index greater than array at index +1, and actually has mountain gets or this, right? So if it already was true, then it will remain true no matter what. If it was false but the condition holds, then it will become true. Now has valley array at index -1 greater than equal to array at index. Well, actually, either two elements are equal, right? And then we don't care what happens there. Or we can't have like a valley, a proper valley. So a valley is array at index -1 is greater than array at index, and array at index is smaller than array at index. It appears to be correct. First is wrong because it has no valley, no mountain. Second is wrong because it has a valley and also has no mountain. And third is correct because it has a mountain and have no valleys. Very good. Oh, I broke it. I broke it. Okay. Very slow. Very slow. And I don't see. Whoa, network error. I actually don't have network problems. Or do I have? I'll be right back because it's obviously unfair. If I have network problems, I can't read the statement, you know? Yeah. Let me pause. We are officially back. I resolved network issues. Yes, I definitely should let the timer go. I want to remove duplicates from sorted array, and it's the second version of this problem. With sorted, we want to remove the duplicates in place. Okay, I think that this is very simple. We don't even need input. We have output index, which we will return at the very end. The loops through numbers. No, we need it. We need it. Input index. Let me also grab length instead. So we have two indices, input and output. Whenever we encounter a new element, the new elements, we change nums at output. We also post increment output index, which we will return in the very end. Yeah, I feel like it might be it. No, apparently I have not resolved all the network issues, but at least we can see the problem statement. Also, I believe a lot of time, like when I finish the problem but keep expanding, is counted toward this tallying. Yeah, but it's okay. I mean, the idea is not to do like plain speedrun, but to explain every problem. So maybe it's like some challenge explanation speedrun. Okay. Actually, you know what? As we wait for it, I would like to have two columns. Yeah. I'm not exactly sure why it became of that color, but whatever. Yeah, so the idea is that values on the right will correspond, like for example, to positions in video approximately where you can find. Hey, what? Ah, at most twice. Okay. So we want to detect three collisions. What's up? Yeah, reading statement is important. I'm not exactly sure why is this gold, but so here we are doing something wrong because here we inserted two here. So here we'll say like, okay, let's go to the next one. Here we'll say like, okay, it's a new one. Insert it here. Here we say like, oh, it's not a new one because the output was changed. Okay. So put equals put. Not exactly sure. Wait. Yeah. Let's just have like value, and then yes. This is the way to do it. So we have current value and how many times it appears. If actually, do we need this? I don't think so. Will loops remembers if number is equal to current value, we increment current count, else value gets number, count gets one, count smaller than one. No, if count smaller than three, then we assign number. And then we return the lens. Is it valid? Let's try it. Okay. I'm not sure why these are golden. Capital. Edit layout. Splits. I want to edit splits. Yeah, I feel like we should pause, or we can't pause. Okay. I don't understand. Okay, whatever. Small subtree with all the deepest nodes. Smallest subtree is that it contains all the deepest nodes in the original tree. Okay. I feel like we need depths. Into depths. Actually, when you think about it. Okay. Yeah, I wanted to write a recursive function for depths, but it won't work. So we will have node.map depths instead. And then I want like depths, which takes reference here. Also tree node. Yeah, so we want to compute like depths only once and do not recompute it all the time. Nice. Yeah, whatever. If not root, depth root equals 0. If not root left, and not right, then root is leaf, and its depth is 1. Otherwise, we should call depth from root left and from root right, and depth from root equals 1 plus max of depth left, depth of root right. Okay, so I computed all the depths by now, I believe. It's really uncomfortable how you can't scroll down. Okay. So we computed all the depths. Now, if depth at root left equals depth at root right, then we want to return root. So because both left and right subtrees have deepest nodes, else if depth in the right is better, and also I will add an initial call. So an ordered map is only created when it's necessary. And I believe we will need reference to it later. I have something like that, so it's really uncomfortable. Yeah, whatever. Let's make it like this and clear it every time we are calling this function. Yeah, I think we will be like that. So here, right subtree is the deepest, and there left subtree was the deepest. What is the error? Somewhere depth is not matched. Wait, like this is not matched. Yeah, I forgot the comma here. Oh, okay, so there is no root or what? Yeah, if there is no root, then we have to return, right? But we don't want to go to root left or right when there is no root. It's correct. Let us. Okay. No, I broke it again. No. And burst balloons, given n balloons from 0 to n minus 1, if you burst this, you get, okay, okay. You can claim by bursting. Okay, so it's just dynamic programming. We, in what time will we try? In quadratic time, we'll have vector db in plan equals nums size. Yeah, so db will contain answers for subsegments, and these answers can be computed from bottom to top. Have a difference between left and right. K is the difference between left and right. Actually, no, it feels like it will be computed in cubic time. Yeah, but we should be fine with like 500. Right is inclusive. Right is inclusive. Right smaller than left, plus left, plus right. For every segment, we check where do we break it. So dynamic programming at left to right gets max of dp from left to right. And we are interested in bursting balloons. Wait, but I don't understand. Like, why here we get 10? We can't burst any balloons. Why? No, 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 no. What is 10? Like, we can't burst any balloons. We have nothing here. Oh, okay. The boundary values are 1. If there are no boundary values. Okay, so we then look for int middle. That's left, middle, smaller than right. No, actually not middle, but burst. So look over the balloon that we want to burst. No, wait, it does not partition. I thought that it partitions everything into two subsegments. No, this is wrong, this is wrong. Can't do it like that. Yeah, I originally thought you kind of like when you burst a balloon, it partitions, but they become adjacent, which means that we by no way can do dynamic programming over subsegments. Actually, now I have to think about it. So we are bursting the balloons wisely. whatever that means. I don't know. I don't know how to solve this problem straight away. Yeah, I may need actually to think. See, LeetCode daily challenges are good. Sometimes you even have to think about the problems. Impressive. No, I actually don't understand. Don't understand. How are we supposed to do like anything? There are too many ways we can do it. So there has to be like some smart approach. Well, if we have only one balloon, that's kind of obvious. Yeah? When we have two balloons, and I'm assuming that we want to burst the smaller first. This is complicated. Obviously, we can't do greedy because first sample shows that it's beneficial to get rid of ones. I'm just interested, can we like somehow go to the next? And skip this one, or can't we? No, it's not a good practice. Let's keep with this problem. Oh, these two are not comparable. No, 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 no. I don't understand this problem. There is something that I don't understand. Can we go to the next? I think that if I press right, then it should go to the next. Okay, we'll come back to burst and balance. Palindrome partition. We're given a string. We want to partition every substring is a palindrome. All possible partitioning. How is that? Okay, okay, okay. So we want all possible palindrome partitions. What if we just loop over all like prefixes and then push back? Yeah, I think this is the case. So if the current string is empty, then we want to return such vector for int. Yeah, let me grab the lens. Wait. If I press okay, so it counts time towards the next problem. Well, not ideal, but I think we can live with it. Also, will it? Okay, so it will show the correct result once we are done. Actually, I have to. Yeah, whatever. Let's say, let's put it this way, and I will add it later. Okay. If for this timer is complicated, people. If let's get the substring, right? From 0 I characters I want to reverse second string. I'm not sure whether or not it's a method like of a string or not. So if the string is a palindrome, then for auto partial answer in partition as substring from I to the end answer implies back answer back pushback actually substring answer back. Oh, then we copy like partial answer begin, partial answer end, answer back. So yeah, and I'm just curious how. Yeah, so the idea is to like we compute for prefixes, right? If the current prefix is palindrome, then we solve problem for the remaining string and we combine the answers. But if it's cubic, because you have to copy a lot of numbers. Why exactly? Okay. So we need to check when the entire string is palindrome. Separately, because then we don't want to go into recursion. Apparently, the first case is not valid. Somehow. Yeah, here we have to check against substring, of course. There's a signal law. Why would that happen? I don't understand. Like in this loop, we guarantee that our substring is valid and also the suffix is valid. Oh, I think it makes no sense to take 0 characters from the beginning of the string. Oh well. No, it's still not okay. What is wrong? I mean, at least we should be able to always pick once, right? And then pick length, so it's length. Oh, wait. Now we are talking. Let me also grab next test case because I'm not exactly sure what is the complexity. Mm, mm. You don't care about the order, so it's okay. We also could have speed this up by storing like solving right to left. For every suffix, compute the answer, then we would not go into recursion twice into the same range. Array nums of one decreasing, return an array of the squares of each number sorted in non-decreasing order. Okay, so what's the deal? I mean, the idea is that you have like negative numbers, right? That's it. Take lower bound nums begin 0. Then we find the index of this element. Then we do what? Like create the output and left gets d minus 1, right gets d, while L at least 0. Yeah, we would also like to grab ourselves a plan. Why L is at least 0, or R is at most len. No, strictly smaller than len. If both are valid, then we have to compare the squares. If nums at L times nums at L greater than nums at R times nums at R, then we output we push back these guys. Also increment R. Also push back like square of left element. Okay. Also have separate test cases when only one of the indices remains valid. Actually, here we decrement L because L goes to the left. And here we have to deal with R in a similar fashion. Numbers are not huge, so they won't overflow. Good. Let's check if this works. Somewhere around here. Appears to be correct. Let's see it. Okay. Validate BST. Okay, we've seen this at the interview, mock interview series. we'll have more episodes of that soon as well. So the idea is we are going to have another traversal. So here we can have auto. Then we call it, then we check if it's sorted. So we can implement this part straight away. So if in order that I is greater or equal to or not exactly sure. Actually, this should fail. Now that I think about, like, in order, if values are there, if there are the same values several times. They can't be. They can't be. It's BST, not multisat. Right. So if there is an inversion, I return false, or otherwise we return true. Yeah, that's actually pass it as an argument because we don't want extra copies. So that and like that, we write a recursive in-order traversal with a slight exception of if not a root return, don't do anything, because you will have like access to bad pointer or something. Also potentially, C++ was not the best choice for speedrun, right? Writing code in Python would be faster, but who cares now? Yeah, I can't type, I'm sorry. I still can't type. Okay, so true, false, as expected. You are absolutely right. BST can't have one value two times, and I forgot about it. Forgot to check something. It really takes so long. Okay. Keep in mind that we have to come back to burst balloons later on. For sum 2, given 4 lists, we want to count a lot of stuff. Okay. such that what? Okay. Cool. Well, we can obviously afford like sorting everything. Also, really don't like how they use capital letter for variable names. What is that? What language has such conventions? Either way, it's turbo. CD. Okay. Now we can compute all pairwise sums of A and B. We can afford it. No longer shows that we need sorting actually. Why don't I use like sets, an ordered set, ordered map? Okay, what's our AI in I, auto J in B, AB put back. Yeah, so we're computing sums of A and B, C and D, and then we're going to combine them in the usual two-sum approach. Then we should have like counter. I don't know, I'm having difficulty. Actually, why I'm doing that, if I can do like that. So the entry here, let's increment it, that's frequency. And then here the same thing happens. So we have like frequencies, how often C plus D attains the given sum. And the same for A and B. In 60, we are guaranteed the tensor is correct, okay. We should do that as well. So now what we do is for auto ABI in AB, answer plus equals to 0. Well, whatever. Answer plus equals CD at min minus ABI. No. For key value, because we want frequencies, of course. So we take minus key multiplied by value, because yeah, we can have multiple pairs for one of the. Okay, I mean it's not very impressive sample test case samples, like not too many samples, but okay, we are done. So we're effectively done, like because eventual initial lists are small, we can combine them by 2 and then use usual two-sum approach, which is of course an ordered map first, second. Then you know the sum. If you know the first entry, then you know where to look for the second entry in the second ordered map. Okay, increasing triplet subsequence. Given an array nums from tree if there's triple sorted. If there's triple in sorted order, okay. Problem is that nums is a bit big. Okay, we have to come up with some smart scan solution. Actually, you know what? I mean, like, we obviously can do longest increase in subsequence, right? And I believe it has like the correct run time. What I mean is that if we are looking only for subsequences of length 3, then we should be fine. Right, right. Yes, we should have some dynamic argument with binary search, I believe. Oh, extra memory. Okay, okay. Okay, I don't know, or do I know? Okay, I don't know. Let's just implement. I mean, I'm not in the mood actually to look for fancy scan solutions. I think we will do like, yeah, so after longest increase in subsequence equals list of norms, return size equals 3. Have or no. This will return a size immediately because I don't want to restore answer. And get some slants size. Yeah, obviously coding for 2 hours straight has downsides, unfortunately. I would like, I think, to have numeric limits int here. I really don't like how numbers are very tough. Potentially we'll need to go into, so D0 is, that's true, be back at the very end. Now here what we do is we look through all positions and take make binary search in dp array, we are looking for the current element, I believe. That's an iterator, and j is the distance, the index of the previous element. dp begin iterator, and if it's valid, that's like that, also like that. No, it's a number. It's a number, right? It's a number. Okay, whatever. Also, it should be dp. And d, we take dp back. Also, int equals p back. And minus 1, I gets pi. This push back dp at I. So we basically found longest increase in subsequence, and we check whether or not it's short, it's long enough. Not m, but len. Actually, it's like previous element already. Also not a, but nums. Actual a. So dp back is a number. Here, I suppose, should do like that. We can like do like that. We add numbers and we go to parent. Okay. So we are accessing somewhere a wrong element. are we actually? We found an element in a TP. And we say like, okay, let's find the distance from this element to TP. And then we check, well, what if j equals 0 currently? No, j never equals 0 because we initialized with min, and min is smaller than any of those. Wait. Yeah, we did not need it. We can search for positive infinity. Then return distance from beginning of the DP to the iter. And we don't have to call size. Keep forgetting about it. I keep forgetting how to implement longest increasing subsequence. What is wrong actually? Because we want to return integer. Well, that was not very helpful. Let's hope it's correct. No, it's not. How did that happen? Here we clearly don't have longest increasing subsequence of length 3. We want exactly increasing, okay. Strictly, I mean. Why did that happen? Separate test cases. We will do this. Here we have -3, 4 for some mysterious reason. I don't understand. Initialized with positive infinity everywhere except for the first, which is negative infinity. And we go through, we encounter 2 we put it here. How exactly? No. Here, distance is what? 1, 2, 3. Should we check like that? Because distance is wrong, like we return one more than we should. Yeah, probably we just return like one more than we should. Okay, terrible. Yeah, programming for 2 hours and 30 minutes straight is kind of difficult. Cherry pick up too. Actually, should I take a break and maybe drink some tea? Yeah. I won't be thinking about problems, okay? I will just go to the kitchen and make myself some tea. Okay, so the break was like literally a couple of minutes. Let's get back to the problem. We're given a grid. Each cell represents number of cherries you can collect. We have 2 robots and they move down. Okay. Okay. Okay, so the interesting part is that we have 2 robots. Like when we had like 1 robot, I believe the solution was, do they have like starting? Yeah, they have starting positions. Okay. So you can just make dynamic programming, entry at, well, actually roll calls are not huge. Or I forgot, I'm very sorry. I believe it was like 1 minute or, okay. And we wasted more time. Oh, okay. So we'll have like dynamic programming, which is will work as follows. We have int rows, which is grid size, calls, which is grid for the size of the first element on the grid, and we have the rows, vector, have like calls, and we have more calls. So the first is a position of the first robot, and the second is position of the second robot. Initially, I would like to initialize everything with -1, that we know which cells are not reachable. No, I should initialize with -infinity. This way, I won't have to deal with special cases later. So dp00 calls -1 gets a 0 because it's a valid starting position. Or should it get like show starting values? Yeah, I think so. Calls -1. Row gets, we will push the values forward. Okay. So to the next row, which means the next row should be a valid row. We increment a row as we go. First call will look like that. I think that it's never beneficial to have them intersecting. but I'm not sure. Okay, so let's cover all possible cases. How did that work in it? Now we look where each robot can go. Okay. So we look how many columns each robot shifts. Okay. All I need to do it first. The first call plus first diff should be at least 0. Most calls not inclusive. Yeah, it may look like we're having a lot of loops, but keep in mind that two of these loops loop over like 3 elements, so it doesn't really matter. And what do we want to compute? Like dp at raw plus 1 first call plus first div, second call plus second div gets max of itself. Previous state, which is of course a raw call, right? Plus then we need a condition. So condition will be like that. If these two guys are equal, I'm sure this is a terrible way to write this thing, but so then grid a row I don't think it's ever beneficial, but to have two robots in the same cell, but we can cover this case explicitly. I should change this to second. A lot of code in last 150 minutes. Yeah, actually all of this can be removed. All of these parentheses, we can remove them. Imagine debugging something like that. I hope we won't end up in such situation. So we get 0. Yeah, I should copy that. Also that. Here it should be raw plus 1. Because we're going to the next row, right? Max and dp calls -1 first call second Oof. Oh, it does not guarantee anything. Don't be too excited about it. I believe by the third hour, nobody is excited. Still. Actually, it looks like it works. It should pass because constraints are very small. Yes, very good. Remember that we have to come back to bursting balloons. Decoded string at index. Decoded string at index. So we have an encoded string. We want to find decoded string. Okay. Well, that's a problem. Okay. So the problem is that we have like huge strings. We obviously can't even try to generate string of length 10 to the 9th. We have to be smarter. I think it involves some modular operations. Okay, how about we compute the length of the string, right? Well, threshold is 0. Auto character string. Character is a digit. If character is a digit, then length get multiplied by character, not by character, but by character minus 0. Else length plus plus. If length is at least k, it means that we kind of already know like we already know by this prefix of s where the case letter is. After that, we should do the for, like if here, if length equals k, we should on character here if length is greater than or equal to k. Should do something about it. So the idea is that in this case we can change k to some smaller value. Make sure it gets alt length. And take modulo alt length and return. Why do we actually return string and not character? And I think that we can return like this. So because we know that current length succeeded it by duplication, and it means that we can look at the old length and then case position corresponds to position to the same position modulo old length. There's only exception like if k got 0, then k should get old length because our position are 0, 1 based for some reason. Not exactly sure that we can return character and cast it to string. Sure, I'll have some problems with it. Let's resolve them. What can we do? Like string 1 and character. Hello. This obviously does not help. Okay. Not a null control path. Well, no, we always return. We return here and here. S is guaranteed to have at least several characters. Whatever. Good. Oh, my head really aches. I mean, how many problems we solved already? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So if we were to solve burst balloons, that it would be like 20 problems. Average time is not bad. I mean, given I'm explaining things, it's not bad. So, given an array of integers, what? Okay, so we can increment or decrement k. We can increase or decrease every value in array by k. Smallest possible difference between max value of b and mean value of b. One possible way would be to do nothing. So to increase everything by k, right? I I think that we are actually interested like in pushing everything towards the whatever median value, but not median value of the array. Yeah. So max, right? Element a begin a end. Yeah, we will try to push every element towards the mean of max and min. But we may encounter problems. Like, what if we push too much? What if k is too huge to push like that? Then we would like to return, then we would like to not do anything, and we can achieve it by adding this, increasing all the entries or decreasing all the entries, right? Or actually, we would like to have it like that. Because if AI is smaller than mean, I plus equals k, what? All those notifications. Yeah, what's up? So if it's smaller than mean, then we increase. Else we decrease by k. And then we do the same thing again. We take max. We don't need this, we don't need that. Like this. Yeah, I will also write that because stable. I feel like we should be good to go. So 1, 3, 6, 3. I believe this is an example of the case when we don't. No, here we want to push still. But if we were to push like that, then we would not want to push. Right? Is it working? Is it? Is it? I have no idea what happened here. Yeah, so the idea was that we increase everything that's below mean value of original minimum and original maximum. Yeah, we need there was original maximum. There is original minimum. We took minimum when we shifted everything here by k and here by minus k. It turns out this is not optimal. Why? It obviously makes no sense to shift this down. Or does it? Or does it? Wait. What will happen if we shift this here? And this will be the distance, right? But when we shift it like that, this is the distance. maybe that difference is more significant than that difference, because this distance is smaller than that distance. Okay, we can do another thing. We can obviously it makes sense. Like, well, mean is not the correct border, but some border should be correct. Okay. So what we will do here, we will sort A, and originally, oh, actually this is okay. We have int answer which is like that at the moment. Oof. So originally we were like to increase everything by k, right? Then we start decreasing things, and we start decreasing things from the max. Okay. So for auto, actually we can ignore the step and in decrease by 2k. Oh, okay. We will do increasing from the smallest to the largest. So get 0, I at most n plus I. We want to increase by 2k current value and check whether or not it helps. So after we do this, I feel like we need some sort of set because it's hardly possible to work with it. Okay. I mean, we can do like that, right? Take the previous with the reference, we take begin with the reference. Only it should be multi-set, I believe. So we then you okay. No, why is it so difficult? We can't do multi-set because we will overwrite. We need to quickly find a new minimum and new maximum. New maximum, I suppose, new maximum is either still an minus 1 or ai. So what is the new minimum? Oh, actually, the new minimum is smallest of two, a0, right? And ai plus first. Let's check whether or not it helps. Okay, I forgot semicolon. Yeah, now it helps. So the idea is that mean border is not always valid, but some border is always valid. So we increase all the values that are smaller than something and decrease all the values that are bigger than something. If it height balanced, right, which left and right subtrees of every node differ in height by no more than 1. Okay. Actually, we would like to have depths again. I guess we just retype it. It will be faster to retype than to try and find. We have also a Boolean variable which determines whether or not this is the initial call. It is, we want to clear previous results of depths and call depths from root. It will compute the depths of all nodes. If root depths gets 0 and return. If not root left and not root right, I mean that the root is a leaf, and depth of root gets 1, else we call depths from left and right subtrees. And the depths of root gets 1 plus max of depths of root left and depths of root right. Okay, so by now we computed the depth of every node, and we would like to return depth of root left. So the absolute difference of depths of two children should be at most 1, and also and also subtrees should be balanced. And this is not the initial call. So we take like that, like that. If not true, I guess we just return true. Right, so then empty tree. We should get, it says which expected expression. Okay, potential can't write it like that, and you have to write it like that. Not a big deal. Or actually, is this necessary? I mean, it was not necessary. Never was. Okay. Next greater element 3, we're given integer n. We want to find next smallest integer child exactly the same digits existing in the n and is greater in values than n. So it's next permutation specifically, right? What we want to do is we want to have digits. Then we want the next permutation from digits. Here we want to do like that, while n digits push back n of modulo 10 and divide equals 10. Reverse digits, I believe. And we would like to, no, actually no. Result next equals 0 for auto next digit in next digits. We would like to add next digit to first we would like to multiply by 10, then add next digit. Now we want next permutation. Actually, it is kind of tricky. It is kind of tricky. No, and can have one digit twice. And also there are too many permutations to check. Or other. And does not have that many digits, right? And it was like 10 to the 9. So we can we handle 10 factorial permutations? I believe there is like beautiful algorithm for next permutation, but I don't think it works when there are duplicates. Actually, I believe it's somewhere in Etcher tools, Python, right? We can look it up. Oh, my brain is literally melting right now. Not because it's particularly warm in here, I believe. Actually is quite warm. No, okay. I don't understand. This is hard. This is very hard. Not particular that not that problem in particular, right? No, we want like bigger than that, so do we? No, we are fine. We are fine with that. Now I want all permutations. Would be so much easier in Python. Next months, we are definitely doing that in Python. Because it's hardly possible. Also, I don't necessarily remember how to write all the permutations. Oh, no, that should be easy, right? If one digits, what? Digits empty. Not return factors. Otherwise, we want to return it, but only after. Very complicated. Take like that for we smoothly generate all permutations. Right? Wait. I believe there is a shorter way to do it, but I'm tired of thinking right now. We can approve it already, or we can ignore it. Here we want to take permutation of new digits. New digits, right? Digits is a vector. We copy digits begin, then next digits begin by I to back certain digits. We also copy from next I plus 1 to and I believe answer in place back. We start with is digits. We do what? We then copy permutation, right? So copy permutation begin, permutation ends, answer back, certain. Should be copy, should not. I'm not even close to being sure that this works. No, it's not. No, it's not. Oh, because we divided it throughout. We should not have done this. So let's grab a copy and then work with the copy. Oh. No. So it was 9 factorial. Is 9 factorial that huge? I don't think it's huge. It's only like what? 360,000. Well, even if we like do 10 times or 100 times this work, it should still be fine. What is that actually? Even worse, we can have something like that. So we are like at least 10 times away. You know what? You know what? Well, actually, yeah. So we take all the permutations of the string. K gets what? K gets, I don't know. Let's say like this. If int from join p is smaller than k, bigger than n, k will it work? Will something like that work? I will be embarrassed by my C++ skills if something like this works faster than my C++ program. Okay, I'm embarrassed. I think the problem is that we copy too much. We copy too much, okay. We already seen this problem somewhere at the interview. Okay, we want swap pairs. Why would we want it? I don't know, don't ask me. There will be a special condition. Yeah, and with that in mind, I actually now think that we will, yeah, we will simply iterate with 2 pointers. So initially we start in the only reasonable manner, right? hands equals next. Okay, so if we have two pointers, want to swap them. Oh no, 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 no. No, 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 no. You wanted three pointers at a time, so the previous is like sandbagging. Wants to change like this too. No, actually, well, let's see what we can do. We currently we want node next to become node next. Right? What else do we want? We want node next to become a node. But we also want to change node itself. Node itself should get node next. Oh, is this it? Is this it? Is this? Is this? Make tuple, I believe, because we have three of them. And I also add like How about that? Where exactly? Line 14. Oh. Huh? Can we do like this? Hmm. Next of the current should become like one that's after the next. Next of the next should become node itself. And node should become yeah, let me draw. We have a couple of nodes. This is node next. This is node next. Right? We say like, okay, like this node is the current node that we are processing. We say like next iteration, we're going to process node next. Node next, that's it, this pointer. Should be changed. Wait. node next should become like that. No, still not helpful. Simply because next of the node should become not this guy, right? Not this guy, but whoever becomes the root in this guy. Recursive call. And here we can therefore change to if. Yeah. Appears to be working. Okay. Diagonal traverse. Whoa, how interesting. Kind of tired, to be honest. Okay, order. At the very end, we will return order. We also have row and column, which are original 0. We also have diagonal, which is originally +1. That's it going upwards, and it will be going downwards. Int rows equals metric size. Rows equals metric size. Or exactly the number of elements in order, right? Int I get 0 equals 2 times calls plus 9. First thing we do is push back. At row column. Now, if row plus, if diagonal is going upwards, then column increases, but row decreases. So if like that, or can't really be true, but what's all. Yeah, it can't be true on the way up, but it can be very well be on the way down. If we again upwards, then we can encounter potential issue as we do this, or alternatively, if we do this, then t gets at -1. So if this happens, then we should increase column. If also this happens, Okay, so we can run out of the matrix in many possible ways. If current column plus, okay, so this corresponds to we went off on the secondary diagonal while going upward. Means that we have to change d to -1, increase the row, and don't change the column. If however we ran off here, that's on the upper side, and we want to remain row the same but increase the column. Okay, good. If otherwise we run on the right hand, then we want to increase row, I believe, and don't change the column. Somewhat similar should happen if we were traveling downwards. So when traveling downwards, we can run out of rows by traveling too far down. If we also travel too far to the left, that it's on secondary diagonal, we're going out in the left lower corner. Then what we want to do is we want to increase column counter. Otherwise, we want to increase row counter, I believe. And if nothing happens finally, it's it's most important statement. Like if nothing happens, then we travel along the diagonal. Here we are ran off on the bottom. How bottom? No. Here we ran off on the left side. Then we increased row. Here we ran off on the bottom side. No, here we increase column. But here we also increase column. Yeah, that makes sense. That makes sense, actually. So you can compactify it like that. So we first check if this happens. If this happens, like then we always do this. If this happens, then we do this. Yeah, I think something like that should work. Like here, if this happens, then we don't care. We always do this. If this happens, we do this, and if not, then we continue travel. Okay, so we ran out of edges somewhere here. Yes, we should flip diagonal. Oh, it's kind of about 1, 2, 3, 4. So that's a matrix of even size. Is matrix always square? No, it's not always square. And we shall. add more tests. So this is like even odd matrix. There should also be matrix like that. Okay. Apparently it looks correct. Oh, come on. Who is interested in traversing empty matrix? Why do we actually like do anything? Ah, here's a problem. Ah, very disappointed test cases. Also very disappointing server response time. Known error. Very interesting. Oh, I should take a break. I'm gonna eat something and drink something. Okay, so I'm back, and I know that on actual speedruns and contests and etc. You can't have breaks, right? But I haven't had my breakfast today because where I am currently, like the last day of the challenge starts at the very morning. So the first thing I did is went here solving problems and then haven't had breakfast. Now I have one, have had one, and I hope that it will help at least a little bit. Yeah, let's head back to our problem. It's decode ways. We have a string of AZ. No, okay. A string of AZ can be encoded as such, understandable. To decode, we make it back. We want number. Okay, it's a classical dynamic programming question. Um, let's say m equals the length of the string. There are no ways to decode, and it's correct. dp0 equals 0 equals 1. So dp at index will denote the number of ways to decode prefix. And how do we recompute it? It's easy. We check the last one character or last two characters, whether or not they fit between 1 and 26. Okay. And we will return dp n on the very end. Yeah, so here dp0 denotes empty prefix and dpn denotes the prefix of length n. Here dp I plus 1 plus equals dp I if string at I does not equal 0, then we can decode one letter, one digit. Also, if I is greater than 0 and s I minus 1 10 times s I minus 1 So we take the previous character, previous digits, we multiply it by 10 and we add SI. Again, subtracting 0 from it. So this is a number formed by last two digits, namely digits I minus 1 and I. And if it is between I don't know. Okay. If or actually this condition should be here because we are accessing I minus first element here. Here we should say like if k is at least 10 and at most 26, I plus 1 plus equals the pi minus 1. And this may be just it. Also want 0, 1, right? So far, so good. No, not good, not good. It did not submit to server. Okay. We have only 6 problems left. Remember, we have to come back to burst balloons. I want to like come back in the timer, but we will solve the problem. Okay, again, an array with the first, jump game 4. There are 6 parts already. Not particularly interesting, it's usually dynamic programming. In one step, we can jump to any element that's equal to ours, right? Or to neighbors. We can jump to neighbors and we can jump to any element that's equal to ours. Okay. I think we can just create graph and then BFS. Am I correct? Let me check. Usually when we create graphs, we like index vertices from 0 to n, but here we will index by values, so we will need an ordered map from in to vector of integers. That's our graph. Now we go for, and let's say array size. If I is greater than 0, then graph at AI should get, I think we need set actually here, because I don't want to have duplicates. So a minus first. No, but if I plus 1 is smaller than n, so insert an image like this into our graph. Do BFX. Also, originally we have like a0. We also want to visit that, which will be an ordered map. Visited. Originally nothing is visited, and that's exactly the state. like false is default value, so that's good. Should we use like distance? Non-BFS empty. Okay, that's BFS size. We process like the entire layer of BFS, right? Vertex is BFS front. So we extract the first vertex from the queue. We want to mark it as visited. If here we will increase it. And it's also always possible to reach, so we will have -1 here, and for the case if something goes wrong. If vertex equals a back, so the last element, can actually access it like -1. We want to return distance, current distance for auto adjacent vertex EU, or we in graph way. If v is not visited, w is not visited, and then w, and that should be it. That should be it. Or actually, when do we visit vertices? We want to visit vertices here, because otherwise we'll process one vertex twice, and that's not exactly what we want. So also visited at main0, that's true. Not here. Yeah, we say that vertex is visited when it's added to the queue. Okay, we will do that later. We have to copy paste test cases anyways. Also, array consisting only of 7. Yeah, because you should not omit parentheses. And just how to get practice. Okay. So in the first case, we reach destination too quickly, way too quickly. Oh, and that's correct. When we actually travel from vertex to itself, it takes some time. No, it's long. I don't want to. Okay. So apparently the initial graph approach was wrong, because when you travel from number to itself, it takes some time. On the right side, we can have now graph as a vector. Also visited as a vector. But no. Like if we have too many. Oh, that's tricky. Okay. We will sometimes have indices, right? But we will sometimes have numbers, right? Very true. We have two types of vertices, like actual element and the value of this element. And I believe that we would like to have like pairs here because this distance is kind of like longer. Yeah, so because we now have like this complicated system from vertex to value and from value to vertex will be 1, so the total is 2. And from one element to other element, the distance will be 2. And at the very end, we'll have to divide by 2. And also, I don't think that we will be able to just do BFS of the Q, because now distances are strange. So we will have to store pairs. Also, we want access to the smallest element. Index is 0, distance is 0. However, this part simplifies a little bit. So when we add vertex, no, it becomes like kind of the extra now, actually. So we have a vertex and distance to this vertex. If a vertex is n-1, then we can return distance by 2. Otherwise, we loop through these. We'd like to have like this and this. Dijkstra doesn't do this. Instead, it has a vector of distances, right? which are initially all 0, or which are initially all plus infinity. Whoa. Okay, it's possible. If distances count, we don't know the actually, by the time we insert, like, distance should be known. So here we check whether distances at v equals dv. If it does, then it's valid. In this case, here. If distance is correct, then we look over these guys. If distances count v. If we don't know the distance to v, or distances to v is greater than this, then we want to set like this. How is that not? Now we're doing Dijkstra, and it should work because there are 10 to the 5th vertices. What exactly happens? Obviously, we do not extract top. -1 is not great result. Is not a great result. But these are backward edge, forward edge, edge from value to index, from index to value. Here we have everything set up correctly, I think. Okay, so for some reason, like Dijkstra runs off vertices faster than it visits everything, which is obviously wrong because we always can get to the next one, to the next one, to the next one, and such on, such on, such on. Right. Of course, first element in the pair is the distance. And second element is vertex. Because distance is key, right? So it should be first. Otherwise, we will like sort according to the vertex ID, which is incorrect. Can I please? What is wrong? But graph is correct. But graph is IDs and distance. But in Dijkstra, first is distance, second is vertex. Here we place as such a distance and vertex. So apparently something is wrong with our Dijkstra. I believe we have it like 100% working somewhere here. Well, and our graph is connected, so we don't have to care about it. Wait, this is not Dijkstra I was looking for. Oh, this is the Dijkstra I was looking for. First distance, then vertex. If distance is correct, also. I just want to say like if is 0 equals en minus 1, we want to return 1 because it's a special case. Or do we? Wait. No, we just want to round up. Okay. Yeah, we round up. It should not help. Like the extra still runs out of edges. So if there's no distance in distances, which means the distance is kind of infinite, or current distance is bigger than what we can make right now, then we update the distance and place element in Dijkstra. I don't understand. It should work. Yeah, let's look at the edges that Dijkstra proposes. Just like here. So in the first case, it's like 0, 0, then 1 minus 100. I would like to know this as well. So we will see from 0, 0, we go to minus 101. From 1, from vertex minus 100 at distance 1, we can go to 0 and 4. Four is this one, right? But then we, because of some reason, we break. Why do we break? No, like literally, it hasn't even processed this vertex. So it's like, I will go to 0 and 4. From first vertex, I won't go anywhere. It's actually wrong because you can go like at least to 2. Maybe I don't understand something. Oh, because distances is bool. So stupid. Yeah, it actually can be like the longest problem we've been solving today. Now the answers seem valid. Let's try. Why would that happen? Oh, because we have like from 2 to 0. No, actually this should not happen. Like we have. No. Everything should be fair. Why do we output 1? 1 is wrong. Like I suppose that we like travel to the second 2, okay? Then to the 0, which makes total distance like 3, but then we should add 1 and divide by 2, and it should be it. It should be 2. Let's take a look at a couple of things. The very last example. We start here, we can go to the value. Oh, because we have values of 0, because we have values of 0. Can I please have something like that? I don't know. And it should cast to integer, right? Now it's valid. Okay. Yeah, and it's indeed going to be the longest problem. What? No, no, it can't be. I mean, no way. We have like 10 to the fifth edges, 10 to the fifth vertex. And I'm assuming that this can be like output size. Yes, okay, good. That was output side because we didn't turn off the synchronization. So 10 to the fifth lines were too much. Okay, okay. Another reaching number. Number of steps required to reach the destination. Oh, I believe this is like, well, first, you have to reach some number, but on the first step, you go like 1 meter, on the second 2 meters either way, on the third step, like 3 meters either way. I believe my hands are not 3 meters long, but you got the idea. Okay, so first we need to at least the total distance is long enough. And then I believe that we kind of can achieve more or less any distance. That is not a sum of distances minus 1. Okay. So I believe the solution was like this. Yeah, I've seen this problem before. So we increment if, and I think we can like target gets apps, target. So if distance is greater than target, then we break. We should remember the value I at which we broke. Okay. We are not doing empty. We are not doing for loops with empty body. Okay. So if distance not oh, okay. I believe the solution was like that. If such, then I plus 1 else I. I think so. I think so. Okay, let's have like 10 test cases should be enough. Oh, it's not correct. It's not correct. It is not correct. Right. Currently, I gets incremented one more way than it needs to. Now it's interesting. Like, I think that we can, like, if we change the sign of 1, then we get like -1. If we change the sign of 2 instead, then we get like -4. Actually, this is interesting. Why did I simulate this this way? Like -4. Huh? then we can have like -6. And we also want D to be of the same pair to this target. Otherwise, our approach won't work. And this is how we check parity. So if it is not the same parity, then we continue. Third times. Yes, now it is correct. Oh, set the palindromic pass in binary tree. Oh, it is harder than I expected. I honestly expected like we probably can do like in 2 hours everything. But apparently there are many problems that I see for the first time. So it takes a lot of time. Okay. No, actually, this is going to be another break because I have terrible headache right now. Sorry, guys. It's just unbearable. Yeah, I'll pause the recording and come back when I'm able to see. Okay, so I'm here once again. We only have 4 problems left. First of these problems is shadow palindromic passing binary tree. It says like you have nodes, values are from 1 to 9. Pass is pseudo-palindromic if you can permute the numbers so that it becomes palindrome. So basically what it says is like at most one frequency is odd, all others are even. And I think the idea is when you do an order traversal, you can maintain a stack. Actually, you can do it like this. So, yeah, let's say we have here like vector int, its frequency counts, initially all 0. We also have bool initial. Yeah. Oh, sorry, I again did not restart the timer. So finish all, then we reset frequency counts, and we do like this. So we increment frequency at root value. Also, when we are at the leaf, so when root has no children, so not root left and not root right. Then we want to check that all all our counts, at most one count is odd, so let me also create the number of odd counts. It's should reset to 0. Here, what should if we change the value and it is now odd, then we add 1. Otherwise, we subtract 1 from the count of odd frequencies. And here we return odd less than or equal to 1. Otherwise, we return the palindromic path of left plus the palindromic path of root. Right, I have no idea if this works. I'm super tired now. So we will just here. No, not like that. Okay, I think we can ignore this. I mean, or only here we have to pass false. Oh. Oh. I don't know how, but I just managed to delete it. Or probably I thought that initialization is not necessary, so I deleted the declaration as well. Where exactly? Okay, so if not root, okay. If not root, return a 0. Only reasonable value to return when there is no root. And it's wrong. And it is wrong. Because actually, when we go away from the I'm thinking. Before we return anything. Yeah, but no. In left. Yeah, in this order. Right. Then we subtract frequency. Left plus right. I should be fine. So the point is that we always have to subtract frequency, no matter what happens. And we did it wrong again. No, but actually, like we have, yeah, we should decrement it after we processed the subtrees. So how it happens? We keep vector of frequencies, right? And then we say like what? If we went to null pointer, then I can, no, nothing ends here, right? If we went to leave, then a leave says like my answer. Oh, because we do not update the count of odd numbers correctly. So that's a problem. Oh no. No, 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 no. Okay, so what happens? Can we maybe ignore all and like always check explicitly? Let's always check explicitly because I'm not ready to think how exactly I should update. So we are still not gaining our correct frequency somehow. Yeah, this should happen right before we return the answer. Potentially that's a problem. Well, our current problem is that we don't have stable internet connection with LeetCode. So I can hardly submit anything. Okay, now I hope that now it works, but I will be not surprised if it didn't. But it worked. Game of life. Okay, we know about conveyed game of life. What should we do? We compute the next step. Okay. No, we want solve it in place. I don't want to. Word source equals. Yeah, so we are going to do just what's told like in the rules of game of life. I believe that's like if you have less than two neighbors or more than three. Yes, yes. Okay. So roles vector calls. Then we just look through all roles. Through all calls we go, also through neighbors. So row delta from -1 to +1 inclusive. Here we should add like if row plus row delta is valid position. Here we should add the same for column. New board row column plus equals board control. Actually, it doesn't matter which way do that. If call there are less than 2 neighbors or more than 3 neighbors. Dice else 1. Actually, no. Here the rules are a bit different. That's always correct. Yes, that's always correct. This, like this. Exactly equals 3, then we get such and such, and let's go. This else is here only for the purposes of not placing brackets. Yeah, so we just implemented the rules, nothing particularly smart here, I believe. Yeah, and of course, in places interesting version, but and there's like some smart traversal when you store information about the current cell and like neighborhood of current cell, and somehow you do it, but I'm not sure. Turn. Okay, so the problem is that we want to assign to board. I don't know what return is. Uh, okay, okay. And so this cell should have died because new board is smaller than 2. Can I please print new board? Like that. To separate test cases, one from another. Very convenient for testing. What can I say? Okay, let's think positive. We only have like 3 problems left. We are almost done with this problem. I believe we have some silly bug. As usual, no. The number of neighbors is 2. And it is, of course, because we included our cell like here. Row delta plus column delta not equal 0. Yeah, we included the cell into its own neighbors. We should not have done this. And this condition is still invalid. What we were aiming for is this condition. Okay. Okay, we only have 2 problems left. Largest rectangle in histogram. Oh no. I remember this problem and I do not remember how to solve it. I remember I was having difficulties some time ago. Sorry, I'm sleeping. 4.5 hours is not definitely not the greatest amount of consecutive working time. Actually, as you can see, it's 5 hours from when I actually started. Right, so half an hour didn't go to the timer because I was like eating or having breaks, and was not so thinking about problems. So actually, like half an hour of breaks for 5 working hours is not much. Okay, so we have what kind of question is that? Don't even know the number of bars. What is that? What? No, seriously. Really? You want to tell us? Okay, well, I think that we can do the following. We will go from lowest to highest, and we will bisect, so divide and conquer, right? If the rectangle of maximum area intersects with lowest rectangle, then it completely contains it. And if it does not intersect, then it lies entirely in one of 2 parts. All right, let's go. I would like to be able to efficiently find minimum. And I think that one way to do it is by range minimum query data structure, some sort of, and I have one just from 2 days ago. I was writing by trace, and I'm pretty damn confident that we had an RMQ data structure here. So let me copy it. So as a data structure, it answers range minimum queries, nothing particularly smart. initialize it with array, then you can query from left to right, and it will tell you the index of minimum element, and in guarantees like it will take at most square root of length for processing, which is usually fine, unless you have like 10 to the power of 6, and it's probably not fine. Okay, so here we ask for clear RMQ. RMQ initialize height. And min index gets RMQ min index. So we just ask him like what's the smallest element on the entire array. What do we do next? What do we do next? RMQ. I keep writing RMW because Q and W are close. So one possible answer. Yeah, let me also add like left equals 0. What section? Yeah. No, I want like from left to right. Because I want to know, so I can like return max of 3 numbers. First will be heights at min index. Yeah, originally doesn't matter, so I can do this. We'll even do like this to not clear it all the time. As such, in the query minimum index or options are then to take the entire thing, to take on the left hand, on the right hand. So from left to min index, not inclusive. The second thing would be from min index not inclusive. So that's it, +1. Right, also not inclusive. So it's n square root of n solution. I believe you can answer RMQ for static arrays in linear time with some fancy LCA data structures like Froch-Galton and Bender algorithm. Something went wrong. Something went wrong. Yes, potentially if left is smaller than right, then we want to return 0. Almost. Less than equal, actually, because right is not inclusive. Yeah, our data structure is not capable of what happens. Should definitely be able to like get at least something here. Don't you think so? Hello? I mean, okay. Almost. I would like to know what is the actual minimum index. What do you mean? Right, damn it. Of course, left is less than or equal to right. Problem is that when it's greater than equal. Very, very long. Yeah, I don't know how I honestly expected it to take less time and we also can run. No, okay. Okay, we are not entirely done because we still have burst balloons problem to solve. Oh, and actually we even earned a couple of coins for week 5. What is going on? Like something broke there. But whatever. Okay, so I guess the total time keeps going like in video at least. I'm not entirely. I still don't know how to solve burst balloons. I honestly don't know. Maybe there's some smart order in which we are expected to process elements. Maybe there are some heuristics, like first get rid of all ones and then do something smarter. I'm not entirely sure what this is all about. Also having, okay. I mean, it's not okay when they don't write in the statements that if there are no left or no right, then we take ones. It's not great. I should definitely submit a report about that issue. Yeah, I honestly don't know. Yeah, okay. I was thinking that I can drag, but I can't. I can't. Just can't do anything. Okay, and I figured out why these 6 first are not go, because I was testing this timer and I accidentally saved some results. Whatever. Yeah, I still don't know how to solve this problem. It's pretty difficult. I guess I will take a short break and come back to you when I know actually. And we will be able to see by my total time. Like I started at 10 a.m. It's now 15:12. So a little bit longer than 5 hours took. I will come back when I know how to solve this problem, and we will be able to see like how much it took me. So final problem, burst balloons. I was actually right. Dynamic programming will do, because when we burst like this balloon, if we treat it like last balloon bursted, then it indeed gets into 2 separate segments. So it was just stupid of me not realizing that we are already done. So we need indeed vector of vectors of units with dynamic programming. It will from dp at ij is the maximum number of coins you can obtain from subsegment from A to J inclusive. So it's all zeros. So diff left equals 0. So now we're just looking over all possible pairs over all possible segments of given lengths, which is diff. And now we loop through all possible indices of burst. We can't. I'm not exactly sure that we. Okay, yeah, we can't burst. Like, I mean, we can't burst left and right inclusive. Then dp at left or right, next from dp on left right, and then dp at left burst -1 plus dp at burst +1 right. And I'm hoping that yeah, let me actually add some statements like yeah, and here you will have lumps of burst -1 times. Actually, here we have like burst equals left. If it does, we get 1, otherwise we get this number. So this is like this is always like this. Now next is similar to first. As is ones on the endpoints are really not convenient. So we get this, and we want to add like from subsegments. So if burst across left, then we don't need to add anything. Also burst equals right. don't have to add anything, otherwise we can do this subsegment, take max, and forget about everything. We took max. We good. We shall return 0 when minus 1. I think so. I really think so. Yes, actually, yeah. It is not difficult. I just did not realize. I just did not realize something very important, apparently. What happens? Like if burst equals left, and I think we can actually write it like this. If this is an endpoint, then we get 1. Otherwise, we get previous balloon plus this balloon plus. Not exactly sure whether or not our DP is correct, so let's give it a try. Maybe the problem is on the diagonal, or I don't know, something. Or something stranger. Yeah, the footage must be very long and very heavy by this moment. Three, 1, 5, 8. So this is indeed correct. Well, here we get 48, which it is not sound correct. No, it is. It is when we take 40 and then 8. Okay, here we get 10, which is correct. Here we get 6, which is correct. On 3, 1, 5, we get potentially, I think, in 3, 1, 5, which is 15 plus 3 and 5. Kind of tricky. If we burst left balloon, then we are not exactly interested in going to this half, and the same goes for right. And I'm thinking that we can't have burst into any of this. That's why we have this condition. It looks like you're not doing well enough. Yeah, let me output left, right, burst. So we can see all transactions, so to say, transitions, of course, in our dynamic programming. Clearly 66 got updated when the last balloon index was 2. So like this is the last balloon that we're going to burst. Where is it? No, it was dated like previously when we bursted 1. Then it got updated, yes. That's correct. So 0, 3 indeed last is here. And 66 or 66 should be obtained like 15, something plus 15. So it should be 51 plus 15. I'm not exactly sure what went wrong here. No, because it's the sum of two. So 66 is indeed 15 plus 3 plus 48. Yes, yes. So 3 and then we have 48 here. Wait, we are interested when the final balloon is 8. So 0, 3, 3 should actually update. Why? Because it says like 8. And then it says like go to, this is the last balloon that you're going to burst. Last balloon that you're going to burst is 8. And it partitions your numbers. Are we actually like interested in different sorts of conditions? Like here you don't have burst equals right, but you have like lambda minus 1. Is this the case or what? I'm confused. Is this the case? Well, it's sort of better. And show that's the same issue here. No, not exactly. I mean, when burst is more than right, yeah, this entry will be just 0. So now, if we take 8, and it says like, the balloons that we are going to burst no, I actually feel like previous conditions were better. Interesting, very interesting. Yeah, well, obviously I'm stupid and we are not interested in taking like this and burst minus 1 and burst plus 1, but we are instead interested in taking a left minus 1 and left plus 1. Correct conditions. That's okay. Now we pass samples and now what? Oh, because I didn't comment the output. Okay. Okay. Yes. Yes. Okay. So only 5.5 hours and 31 problem solved as such. I think this was actually, how fast was this? Let me think. Let me figure it out. So we have like 5.5 hours. So 5 hours is 300 minutes. We have like 330 minutes over 31 problem, approximately 10 minutes per problem. And obviously it's not all that fast, but we also explained something. So yeah, I think it was sort of helpful. I mean, especially in the beginning when I was like actually solving problems. And I think I was explaining much better like around here before burst balloons. And then it went just like several mistakes resulted in sort of long recording. But I still hope it was helpful overall, and it was a lot of fun recording it, although I'm really exhausted now, right now. I don't think we'll have like, I originally thought like, oh, well, we'll have quick speed run and then we'll have like code forces training. But now I realize that I'm not in the mood for doing any more programming today. So potentially code forces training on minimum spanning tree will be coming tomorrow and not today. I hope you enjoyed, hope it helps, and see you in the next episode. Yeah. See you in the next episode.